Hi, it's Mr. Hamilton. How do we go from that equation in standard form to this equation in vertex form? We're going to complete the square using this example and then one where the numbers don't work out quite as nicely, but we'll see it still works. So, determine the maximum or minimum value of the following parabola. Y equals 2x squared minus 12x plus 14. Now, the idea with completing the square is that we first common factor the coefficient in front of the x squared term only out of the first two terms. So we're going to go ahead and we're going to common factor out the 2, and we're going to be left with x squared minus 6x. And we still have the plus 14 at the end. So now what we do is we take the 6, we divide it by 2, and we square it. That's 3 all squared, which gives me 9. And so what I now do is I'm going to change nothing, but I'm going to change something by actually adding and subtracting that same number. So I'm going to add 9 and subtracting 9. That really changes nothing because I'm not adding anything, but it is changing it in terms of putting it in vertex form. And so now what I'm going to do is I recognize that these three terms right there are a perfect square. And so what I need to do is I need to take the 2 and I need to multiply it by the negative 9 at the end. And so what this gives me is it gives me 2 times x squared minus 6x plus 9. And then the 2 times negative 9 gives me minus 18. And then we still have the plus 14 at the very end. And so this becomes y equals 2 times, this is a perfect square, so we take the square root of the x squared term, which gives me x, the square root of the 9, which gives me 3, and then the sign of the second term, which is a minus. And so it's x minus 3 squared minus 4. And so that means that the vertex in this case is going to be at 3, negative 4. Well, let's think about also if that's a max or a min. And the way we determine that is we look at the a value. We look at the term in front of the x squared term. That's the same a value, by the way, as in the vertex form. That will be the same value in all the different forms of a parabola, whether it's standard form, vertex form, or even factored form. So in this case, because the a value is 2, it's positive, that means that the parabola opens up. So if it opens up and it has a vertex at that value, that means it is a minimum at 3, negative 4. And just as an added bonus here, let's do the domain and range. Every parabola has a domain where x is all the real numbers, so x keeps going on and on forever, out to the right or out to the left. But the range is restricted based on that vertex. And so the range, y, is a set of all real numbers, such that, well, in this case, because it's a minimum at 3, negative 4, this is the y value, and that's the lowest it gets. So that means that y has to be greater than or equal to negative 4. And so there's the domain and range as that minimum at 3, negative 4. Let's look at one more example here. So for this second example, the numbers don't work out quite as well, but I want you to see it still works out just as well. So here we go. We're going to go ahead and we're going to common factor out the negative 4 out of the first two terms. So out of that term and out of this term. So y equals negative 4. We're going to be left with x squared. Now 6 divided by negative 4 is minus 1.5, or 6 over 4, 3 over 2, which is 1.5. So we get minus 1.5x. We still have the plus 10 at the end. So now what we're going to do is we're going to take the 1.5, we're going to divide it by 2, which gives me 0.75, and we're going to square it. Now notice 0.75 squared, that's going to be that 0.75 is going to come back in a minute here. So that becomes 0.5625. And so what we do with that number is we add it and subtract it inside the brackets, changing nothing but really changing it into the form we want. So we're going to add it and then subtract it again. And now what we can do is we can bring that last term out, the negative 4 times the negative 0.5625. This actually gives me, when I go ahead and I write out what I had for the first three terms, I'm left with positive, because negative times negative, 4 times 0.5625 is 2.25. And then we add that to 10, and now we have a perfect square right there. And so we get negative 4 times x, the square root of the 0.5625, which, by the way, is always the term that I squared up above. So it's 0.75. And then the term in between them is a negative, so it's minus, all squared. And then we take the 2.25 and add it to the 10 for 12.25. So what that means is it means there's a vertex at 0.75, because it's x minus h. So if it's subtracting a value, it's always a positive x value at the vertex, and then plus 12.25. So the y value of the vertex is 12.25. So we also again look at the a value. So the a value is right there and there, same a value. And so because a is -4, that means it opens down. And so now in this case, because it opens down, it means that it is a maximum at that vertex value at 0.75 and 12.25. So we could also list the domain and range. A little added bonus, as I noted. X is always a set of all real numbers unless it's a real life situation that has some practical restrictions due to time or something. But the range is always going to have restrictions. And so in this case, y is a set of all real numbers. And because it opens down, it's a maximum at this y value. That means that y has to be less than or equal to 12.25. And there you go. There's two examples about how to complete the square to find the maximum value of a parabola. There are actually lots of other ways to find the maximum or minimum other than completing the square. For a video about that, check out the one on the left. On the right, you'll see a video all about graphing in vertex form. Thanks so much for watching, and I hope this was helpful.